All right, we're continuing our MechFest. We're going to do hemiacetal again, this time with a specific example. Here we put a carbon group there, so R is equal to carbon from our previous page, so CH3. And I changed up the ketone to an aldehyde, but that doesn't really change anything. And what's your first step? Carbonyl activation. Carbonyl attack the strong acid. You're both correct. There you go. Activate the carbonyl. We won't write those words. You don't have to write those words, but you have to do it. Equilibrium process. We'll talk about Le Chatelier later, if I can remember. Here we go. Activated carbonyl, even a lousy nucleophile like methanol. Okay, that's strange. Methanol can attack a activated carbonyl, otherwise not interested. And upstairs we made HO3SO minus in the first step, and we're using it to protonate or deprotonate our oxonium, depending on your perspective. Hemiacetal. So before we move on, what is a hemiacetal? Let's put a definition. Has a carbon that is simultaneously two functional groups. I need you to list them for me. And oh, you both nailed it. One person said alcohol, and simultaneously another person said ether. Very happy teacher here. And alcohol and ether. If you have that situation, you have a hemiacetal, and this is the carbon we're talking about right there, right? It's got an alcohol above it and an ether to the right. Okay. So what we have to do is we have to get to another activated carbonyl situation. Remember that. If you want to put a new O on, got to get an activated carbonyl. And what has to leave here? Take a look at the reaction. Okay, the H has to leave from the, well, the H is going to take something with it. Or are you talking about methanol's H? Yeah, I'm talking about here. What's got to leave from here? Okay, the OH, I agree. But take a look at the products at the end and tell me how the alcohol leaves, because that's a hint what you need to do. It's got to leave, but it has to leave with two H's on it, and currently it does not have two H's. Tell me what you think the first step is. Okay. She's a little ahead of what I want to be at, but I want to protonate it first because that's consistent with a discussion we've had many times. What's the purpose of protonating it here? I mean, you could say activate, but that's just, you know, you're excited about this new word you'll learn, but she said it. She said, make it into a good leaving group. Yeah, we've done that before with OHs. It's not the first time. Protonate to make a better leaving group. Equilibrium again. Everything's equilibrium. Every single step today. Well, today, that's harsh. Most steps today are equilibrium. What do we got? We have the iso. We have the C with the O, which now has two H's. It'd be leaving soon. And then we have OCH3 in black down here. And big fat hint here. That's a big fat hint there. Why is he doing that lone pair there? Because we're going to do what this young lady over here told me to do, make a pi bond. I'm going to kick that leaving group off with that lone pair. And when I do this, what kind of a bond am I making? Right there.
Pi bond.
Pi. It'll be a oxonium with a pi. It'll look just like, well, almost like this thing, right? Yeah. And this is going to leave. So there's your water situation. We could do something, I don't know. I'll try. This doesn't always work. You got the water situation. And what else did you get? Plus this thing. Put plus in. Isopropyl. Double bond to O here. And I will write activated carbonyl here. Just to jog your memory about what to do next. You had an activated carbonyl on the far left of the screen. What did you do next then? Methanol attacks the activated carbonyl. And yeah, we have, what's this symbol mean here? XS? You have a lot of methanol, excess, like spread, make that into a word just from the sound. You know, I like that stuff. Sounds becoming words all over it. But anyway, that's just me. Methanol is going to attack the activated carbonyl. We have methanol up here. Why not use it way up here? Throw a lone pair on it. Here he comes. Ooh, almost missed. I'm going to start that over. Yeah, that didn't miss. Okay, and that's going up here. And we're going to have something looks very similar to that final acetal. This is our first acetal, isn't it? Of course, I'm going to be asking you for a definition of acetal, and you're going to have it ready for me. Still has the extra H. There's the OCH3 from before. And we generated an sulfate ion. I guess we generated it way down here. And I don't know. That sure is far away, isn't it? Got a lot of style. And yeah. Okay. Acetal. Oh, why don't we just use this? You gotta love it. He's defining a new word, and immediately he uses another new word. What's going to be after di? Ether. We talk American space history now? Mm-hmm. So what was the mission that landed a man on the moon? And it happened. Okay, what was the name of the mission? Apollo. What was before Apollo? No. It's the first time they put two people in space. Two people. What would be a nice astrological symbol saying two people going into space in a little confined area? Gemini. Yeah. What's Gemini the sign for in the astrological spectrum? Oh, it's okay. It's not really science, okay? So it's okay if you don't know at all. Personally, I am a Leo. So I'm the lion, right? The roar. And Gemini is twins. So what's geminal mean in organic chemistry? Twins on the same carbon. Yeah. Okay, so geminal is Geminal you should learn with vicinal. They are brothers. Geminal, two guys at the same house, they live in the same place, right? Vicinal, they're next door neighbors. I'm glad it came up. We just did spectroscopy. We're talking about neighbors all the time. That was vicinal, right? Geminal reminds me of C13. The carbons had patterns because of the H's that were attached to the carbon. The H's in the house, right? So those H's that were together there were all geminal. Okay, new words, new functional groups. We're going to use these functional groups extensively every test, both hemiacetal and acetal. They don't go away ever. So we're going to do another activity where we do hemiacetal, acetal. Why not? Coming right up.